Okay, hi everyone. So I think this is we're having a last session of the NOG event, and yeah, I think I need to be here a little bit longer because I just did like 2 of the 10 question the quiz. So yeah, I'm talking about the two roles about the internet exchange point, and maybe I a little bit want to also introduce myself. My name is Michael. I'm based in Indonesia. My background is a technical things. So yeah, I doing the technical and operation in my ISP, and I also the board member of the IIX Indonesia Internet Exchange. It is one of the biggest exchange in Indonesia. We have around almost 16 of the terabit of the traffic, the peak traffic. So yeah, maybe my presentation will be a little bit quick because I think it will be a lightning talk. So there is some misconception, maybe in some European countries especially, they have when we connect to the IXP, we have like maybe like 300, 200,000 of prefix when we connect to the IXP. But actually, it's not the whole internet. We still need the IP transit to serving the internet itself. And yeah, IXP not doing the routing. They only do the switching. So basically, it's just a switch fabric. But maybe in the some modern IXP, they also deploying some VXLAN or maybe ASR physics to having more robust and resilient infrastructure. Yeah, the bigger network now, maybe we have a huge of broadcasts and maybe misconfiguration from the engineer. And maybe some misconception also happen is when they connected with an ISP, it can improve your latency. But actually, it's depending on how you can manage your routing configuration. So yeah, what is the internet exchange point? What it is? It's not a replacement for transit. It's only about how we can exchanging the traffic and how we can reduce the interconnection. I mean, we only connect with one switch and then we can meet each other in the same broadcast domain or in the same network. And so we can do the routing. We do the BGP, not with DIXP. We do the routing directly with the network without the ISP doing the routing. The route server that maybe we see in the ISP, they are not doing the routing. They only do the BGP signaling, so the traffic is not going through the route server. So yeah, basically it's just do switching. It's a switch fabric, and yeah, there is some maybe like peering agreement. Many of networks maybe just connect with the switch fabric. Maybe we need to set up some agreement to do what we call is a bilateral peering, and maybe they have some specific policy to control their own traffic, and maybe some non-technical things also influence the condition itself. So yeah, this is the topology. It's pretty simple, right? I mean, there's a lot of the IXP now, even in Indonesia itself. Maybe back then in 20 years ago, we only have 2 IXP, but now we only have like maybe 60 or 50 IXP now. There's a lot of people creating a small ISP, sorry, a small IXP, and yeah, they ensuring the traffic is keep being local and not going overseas or something. Yeah, this is some characteristic and the key traits of an IXP. Yeah, it's a switch fabric and reduce the dependence on the transit. It can be lowering your costs because you only yeah, you can imagine it, yeah, you can just deploying one interconnection to one switch fabric, and then you can meet a lot of networks. Maybe not everything, but yeah, you can meet with a lot of them. And it's improved the routing efficiency because yeah, you can comparing the routing and the switching performance and capacity is totally different. And of course, it's also encourage the regional internet growth because yeah, the traffic is keep being local. It can reducing the cost, and then you can just meet in the same room without getting anywhere. And yeah, you can also operate with the route server. You can establish one BGP peer, and then you can getting all of the prefix and the network that the route server have. And yeah, cost effective. Yeah, direct peering between each other, and also make sure the traffic keeps local. And yeah, I have some cases actually. I also do something like the remote peering. It was happening from Singapore. The traffic is it should be just meet in Singapore in the same country, but uh, unfortunately the traffic is going to Amsterdam first and then going back to Singapore again. It's increasing the latency like 200 millisecond or something. Yeah. So if you connect with the ISP, please also ensure that your peering partner is having the networks in the local area. So it will not be effective if we connect each other, but it will be double the cost, double the distance, double the latency and everything. So we need to make sure maybe we can check the latency. We can add the IP range to our monitoring system, and then we can try to adjust some BGP configuration like local preference, ISPAC prepending. Yeah, there is a lot of the things that we can do with the BGP configuration. We can manipulate the metric. Yeah, I know the BGP is doesn't depending on the latency, so that's why we need to cross-check it maybe one by one, or maybe we can also do like BGP community to do the selective advertisement to ensuring the traffic is going to the right path. So yeah, this is the simple topology. If we don't have the IXP in our local region, the traffic will going to the tier 1 network first and maybe going to the overseas. Yeah, let's say maybe from Vilnius, we want going to Kaunas. How we can imagine if the traffic going to Frankfurt first, it will double the cost, double the time, and double the latency as well. Yeah, so with the internet exchange, we can uh, substitute the latency. And maybe if you have some huge traffic, we can also do the PNI, private network interconnection with the some content provider. But yeah, you know the costs will be. You need to check the cross connect costs between inside the data center itself. And yeah, this is the comparison table. The purpose is totally different. IP Transit is giving you the global internet access, and internet exchange point is giving you the local traffic exchange. So yeah, I'm not saying doing the remote peering is bad. Sometimes when we want to having the best path going to some area, maybe we can do the remote peering, but please also make sure your routing configuration as well. And yeah, the connection is not routed. We do the routing directly between the networks if we have the IXP, and it is layer 2, faster than routing, of course. And usually the IXP charge you port base 1G, 10G, 400G, 800G, and yeah, if IP transit, they will charge you by the capacity itself. And latency, yeah, it should be lower because it's just a switching, but yeah, we still need to ensure the configuration itself to make sure the traffic is not suboptimal path or something. And yes, IP Transit do the BGP, but IXP actually do the BGP signaling only in the route server, or maybe we can do the BGP peer directly from the network each other. Yeah, this is the basic requirement. the ES number, public IP prefix, the port, and the router itself, of course. And the most important things is the willingness to peer, and please also be communicative, because with more IXP, more ecosystem, it will be increasing the complexity. So if you be communicative, it will be easier for us as an engineer to troubleshoot some network issue. Maybe some people hard to getting. We send the email and then they will reply the email in the next month or something like that. Please also be communicative as well. It's the most important things. And well, yeah. The conclusion is IXP is not the epitransit. An IXP is simply help you to interconnect with other networks.